So today we're going to continue our rates of change. So the first thing we're going to talk about today is linear functions. And you guys know this, a linear function, the average rate of change is constant, right? Our slope is always the same. And so again, we've always referred to it so far as slope, but we're also going to see it a lot in this course as average rate of change. So if we have a table, how can we explain that this is not a linear function? Well, if we take the points 1, 4, and 2, 7, and if we take a look at the slope, let's see, 7 minus 4 over 2 minus 1, we get 3 over 1. Now, if we take the slopes 2, 7, and 4, 10, let's see, we have 10 minus 7 over 4 minus 2, we have 3 over 2. So the slope is not constant. Now, we talked about this a little bit in our last unit, and we're going to take a look at it again. So if we're going to take a look at x squared, so, and you'll notice here we have equal length input values. So these are going up by 2. So 3 squared is 9, negative 1 squared is 1, 1 squared is 1, 3 squared is 9, 5 squared is 25. So now this is saying what is the average rate of change from negative 3 to 1. So it's saying take the points 3, 9, negative 1, 1. And let's see what that is. Well, 1 minus 9 over negative 1 minus negative 3, negative 8 over 2. So is negative 4. Then from negative 1 to 1. So this next one. So 1 minus 1 over 1 minus negative 1. 0 over 2, so we have 0. Then from 1 to 3, 9 minus 1 over 3 minus 1, 8 over 2, which is 4. And then we have 25 minus 9 over 5 minus 3, 16 over 2 is 8. So we can see that they are not the same, but if you remember from last time, what is our change here? It's going up by 4, up by 4, up by 4. So what do you notice about the average rate of change over consecutive equal length inputs? So again, they're those equal lengths. So the average rate of change, so that's this column, is the change, I should say, the change in the average rate of change is constant, or sometimes you might see it's like linear. So the change of the average rate of change. So you it's a wording thing here. So our average rate of change is that first difference, and then the change in that. Sometimes you'll see it that the second difference is the same, which we talked about. So on these, let's see, determine if it's linear, quadratic, or neither. So the first thing I notice is these are all going up by 1. So that's nice, equal length inputs. So this is going up by 1, 3, 5. So what would our difference be? 1 over 1, 3 over 1, 5 over 1. So 1, 3, and 5. So it's going up by 2. So the average rate of change, the change in the average rate of change, and I'm an average rate of change is constant. So it would be a quadratic. So this one is going up by 1, 3, 5. This one is going up by 1, 3, 5. So 1 over 1, 3 over 3, 5 over 5. The average rate of change is constant. So it would be linear. And then this last one, let's see, it's going up by 2, 2, and 2. So this is going up by 2, 1, and 0. So we'd have 2 over 2, 1 over 2, 0 over 2. So this is equal to 1, 1/2, and 0. Well, it's going down by 1/2. So the change in our average rate of change is linear because it's going down by -1/2 each time. And again, that second difference is the same, so it is a quadratic. And now we're going to tie this to what we did yesterday. The average rate of change over equal length input is, so when we think if it's concave up, what is happening to our average rate of change? Well, it's negative 0 to positive, so it is increasing. We're concave down, right? It is positive 0 to negative. Positive 0 to negative is decreasing. So if we had to decide whether these are concave up, concave down, or neither, let's see. So 3, 2, down 2, down 1, and this is 0.1, 0.1, 0.1. So negative 3 over 0.1 is negative 30. Negative 2 over 0.1 is negative 20. Negative 1 over 0.1 is negative 10. So those are increasing, so the average rate of change is increasing, so it's concave up. So our next one, 3, 3, and 3, 0.1, 0.1, 0.1. So all of these are 3 over 0.1, so it is constant, so it's neither, right? So if it's constant, it has to be linear. In this last one, so this one would be 6 over 0.1, 4 over 0.1, 3 over 0.1, so 60, 40, 30. Our average rate of change is decreasing, so it's concave down.